So what is relation? Hmm? What is a relation? To define a relation, you need a set. Hmm? You need a set. Without set, you cannot define relations. You should have two sets, no? Right? Two sets. Always relation defined from one. So you match elements of one set to elements of other set, another set. Right? For example, so you have set A, let's say set A, like that. Is set A, 0, 1, 2, 3, 4, 5. Okay? Set B, you have 2, 4, 6, 8, like that. Okay? Then how do you uh, connect elements of A to elements of B? Hmm? What is the connection? So 0 connected to 2. Hmm? 0 connected to 6. 1 connected to 4. So it's a one relation. Certain relations. So you can write many relations between A and B, from A to B. Hmm? From A to B. So relation you can say like then. So you can name the relation as R. Let R be R1 be a relation. 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 So in that relation, 0 R1 2. That this means 0 connected to 2. Then 0 connected to, so 0 related to 6 also. 1 related to 4. Right? So this relation you can give like that. Or you can give this relation, so R1 0 equals 2. Or just like a function. But these relations are not functions. Functions have some special properties, right? But 0 related to 6 also. Uh, 1 related to 4 also, like that. So you can represent this relation in different ways. Okay? 0, 2, 0, 6, 1, 4, like that. Same relation. So how many ways you can represent this relation? So this relation you can represent like this. Two tuples, 0, 2.
Like why 0?
0, 6.
So
1
R1, 2, so 0 R2, 6, 0 R1, R2, 4. What are they?
So same relation you can define in different way. R1, this R1 relation is 1, not 2, 1. This R1 relation, so you can represent it in 3 different ways. The relation R1 R1, which is from capital A to B, can be represented in three different ways. Okay. Right? So this is also same relation. R1, 0 connected to 2, 0 connected to 6, 1 connected to 4, like that. So like this also you can define, right? So these are the three different ways. Three different ways. Right? But in this lesson we use this method, like a set. So this R can be represented in the form of a set. So this is a set, subset. Subset of what? R1 is subset of, what is the superset of R1? What is the superset of R1? What is the superset? So that each relation is subset of each relation is subset of it. What is the superset? Hello? What is the superset? Superset is A cross B. You know how to write A cross B, no? Hello? All these relations. So you can write many relations too. Not only that. Shall I write A cross B is the superset. All relations. So you can write many relations. All those relations are subset of A cross B. Right? What is A cross B? So you take all possible relations. So 0 to 0 4, 0 6, 0 8, 1 3, 1 4, 1 6, 1 8, 2 2, 2 4, 2 6, 2 8, 3 2, 3 4, 3 6, 3 8. Then you can take 4. 4 with 2, 4 with 4, 4 with 6, 4 with 8. 4 2, 4 4. Right? So you take 4 2, 4 4, 4 6, 4 8. Right? 4 2, 4 4, 4 6, 4 8. then 5 2, 5 4, 5 6, 5 8. So this is. So if you write any relation, each of the relation is subset of A cross B. So therefore A cross B is the superset. A cross B is the superset of all those relations. All those relations. Can you write another relation R2? I will write another relation R2. 0 4 1 6 4 8 5 2, like that. So this is relation, second relation R2. Likewise, you can write down many relations. What is the cardinality of A? Cardinality of A is 6, no? Cardinality of B is 4. What is the cardinality of A cross B? What is the cardinality of A cross B? Hello?
Yes, sir.
What is the cardinality of A cross B?
Cardinality of A cross B is 24.
24. That's right. Cardinality of A cross B is 24. Then there are 24 elements or 24 members in A cross B. Then how many number of relations? If you write down all the possible relations from A to B, how many relations are there? Hello?
Yes, sir.
If you write all the possible relations, so you can write many relations. How many relations are possible? Number of relations. Total number of relations. So you can write R1, R2, R3, R4, R5, R6, like that. Many relations you can write down. How many relations? Number of relations, total number of relations.
Sir, I don't know what the superset means.
Superset is A cross B. Each of subsets is subset of A cross B. Now R1 is a subset of A cross B. R2 also subset of A cross B. So if you write another relation, that is also subset of A cross B. Then we say A cross B is the superset of all those relations. Right? Okay? Can you tell me another relation? R3? Just tell me another relation. Hello? Very simple. You just pick up from few elements from A cross B, then that's a relation. If you just take a subset of A cross B, that's a relation. Tell me one relation of A cross B.
0,
0, 3, okay. Is that all?
no, sir, 0, 3 is not there.
Yes, 0, 3 is not there. Yeah. You can't take 0, 3.
0, 3.
0, 6. Okay. 0, 2 is there, no? 0, 2 is there. 0, 6 you can take, yeah. Good. Is that all?
One four.
1, 4. Yes. 1, 4.
Can we take 1 6 because R2 already has 1 6.
1, 6.
R2 already has 1 6.
Can be, but can take. Why can't it? To be always maybe intersect 4 may not be intersect. Right? 1, 6, yeah, no matter. You can take. If you want 0, 4 also, you can take. 0, 4 also you can take. Right? If you take same set of elements, then R2 and R3 equal. That's all. Now these two are not equal. Okay? But 1 4 is in R3, but 1 4 is not there, not in R2. So R2 and R3 are not equal, right? Okay. Can you tell me another relation, R4? Hello?
So 4 4.
4 4,
4 6.
4 6,
4 8.
4 8. So you can write many relations. I am asking how many relations are there? Total number of relations. How many relations? Cardinality of A cross B is 24. Then number of relations. Relations equals 2 to the power of 24. 2 to the power of 24. Big number. That means all possible subsets of A cross B. If you take any subset of A cross B, that's a relation. Right? That's a relation. So, number of subset means number of subsets 2 to the power of 24. Right?
So why is it 24?
So,
Because of the cardinality, sir. Because of the cardinality.
cardinality. Cardinality A cross B, cardinality of A cross B is 24.
Yes, sir.
Then you can form 2 to the power of 24 subsets.
Yes.
Right?
Yes.
We discussed this in last lesson. We comprehensively we discussed this thing.
Yes, sir.
Do you want to discuss it again
No, sir.
comprehensively? Now, you know that suppose let's say Y is a subset, Y is a set. Y has A, B, C. Then how many subsets are there? How number of possible subsets? Then so A, so you can form single element subsets. Sets with single member. Then sets with two member A, B, A, C, B, C. And taking all members A, B, C, taking three members at a time. And null set also subset of Y. right? The entire set is Y. Y also is Y actually. Y also subset of Y. These are all the subsets. How many subsets are there? If you count 1, 2, 3, 4, 5, 6, 7, 8. Okay? That is 2 to the power of 3. 8 subsets. Okay? Is it clear? Hello? Right? Suppose if we have these sets, let's say, uh, let's say Q. The Q has, these are the elements. 1, 2, 2, 0, 3, 1. How many subsets are there for Q? Number of subsets of Q. What is the cardinality of Y? What is the cardinality of Y? 3. That 3 comes here, right? Okay. Cardinality of Y is 3, right? So this set is known as power set. This set is PY, power set. Set, sets of set. Power set includes all the subset of Y. PY means all subsets of Y. Right? Okay. Is it clear? Mm. Then how many subsets are there? If you write all the subset of Q, how many subsets are there? If you write all the subset of Q, how many subsets are there? Hello?
So all the subsets Q?
Yeah. If you write all the subsets, how many subsets are there?
The 2 raised to 3.
8. Yes, 8 subsets. Because these are the cardinality of this one is Q, cardinality of Q is 3. Then you can write 2 to the power of 3 subsets. That is 8 subsets. Okay? What are those subsets? Null set. Then 1, 2, 2, 0, 3, 1, 1, 2, 2, 0. Taking two members at a time. Right? 1, 2, 3, 1. So you can take, you can select two members in 3 different ways. 2, 0, 3, 1. Okay. Two members can be selected in 3 different ways. Then you take all members, that is key. So like, this has 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. Okay? There are 8 elements in this, right? Right. So this is PQ, power set. Okay? Right? Now, if you take this one, now R1, R2, R3, R4. Those are relations from A to B, no? Okay. So I will right. Now, all these relations R1, R2, R3, and R4 are relations from capital A to B. Okay? So, in order to obtain these relations, as R1, R2, R3, R4, so you have to consider A plus B, no? A plus B. Okay? If you want to write relations on A, then how do you write relations on A? What do you mean by relations on A? Are the relations R1, R2, R3, R4 relations on A? Hello?
Yes, sir.
No. R1, R2, R3, R4 are relations from A to B, not relations on A. What do you mean by relations on A? What do you mean by relations on A? How do you write relations on A? Capital A? Hmm? The above relations R1, R2, R3, R4 are relations from capital A to capital B. From capital A to capital B. Relations between two sets, capital A and capital B. What do you mean by relations on A? Can you write relations on A? Relations on A means from A to A. This means right relations from A to A. You can write relations from A to A. Relations from A to A is known as relations from A. It's in shortened form. Relations from A. So if you find anywhere relations on A, that means relations from A to A. Right? Then you need to find A cross A. If you want to write relations on A, so you need A cross A. Right? What is A? Right? What is A? Where A equal, what is A? From 0 to 5. A is from 0 to 5. Zero, 1, 2, 3, 4, 5. You know how to write A cross A, no? A cross A. You know how to write A cross A. Not A cross B. Now you have to write A cross A. A cross, these are 6 elements. Then you can write 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 1, 0, 1, 2, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 4, 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. So this A cross A. The number of, what is the cardinality of A cross A? What is the cardinality of A cross A? Hello? What is the cardinality of A cross A?
It will be 25.
No. Which has 60 elements. Cardinality A is 6. Then what is the cardinality of A cross A? Huh?
54.
54 or 54? 16 to 60?
64, sir.
No. Not A cross B, this is A cross A. Partial product A cross A. This is partial product. Partial product
36, sir.
36, yeah, 36. Because A, cardinality of A is 6, no? Then cardinality of A cross A is 36. If you count, you will get 36 members. Then set A cross A has 36 members. Then how many relations on A? Number of relations. Number of relations. On A. How many relations are there? Now if we choose any subset of A cross A, that's a relation. That means number, if you can find the number of subsets, that is the number of relations. Okay? The number of relations only, how many relations are there? Subset A. How many relations on A? Number of relations on A? Number of relations on A means number of relations from A to A. From A to A. Hello? 2 to the power of what? Hello?
The number of relations is 2 to 6. The 2 to 36.
2 to the power of 36.
36.
Yes. 2 to the power of 36. Very big number. Right? Okay?
Yes.
2 to the power of 36. So you can form many relations. Many relations. Then properties of relations. Properties of relations. Now, there is a relation on a finite set. Now, A is a finite set, no? A has 6 elements, 6 members. So it's a finite set. If you take infinite set, what do you mean by infinite set? Infinite set, like set of integers, right? Relations. On issue. Relations on issue. Where issue equal set of integers. Set of integers. That is from minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, 4, like that. From minus infinity to plus infinity, all integers. Right? So minus infinity plus infinity. This infinite set. Why this infinite? This has infinite number of members. Right? If you write a relation on Z, can you, how to write a relation on Z? R1. R1. You can write like that. X, Y, right? X, Y. X minus Y is divisible by 5. Right? So this is a relation. Can you write a finite relation? So you can write infinite number of relations. No? You can now here this, although this 2 to the power of 36, this finite, no? Big number, but it's finite. No? Finite number of relations here, no? The A is finite set. If you take finite set, you can write down only finite number of relations. If you have infinite set, now is a set of integers is infinite set. How many relations are there? How many relations can you write on this infinite set? Hello?
Yes.
Can you tell me one relation? Can you tell me finite relation? Is the R1 is finite relation or infinite relation? Can you write finite relation? I will reject this one. You just write, tell me pi, can you tell me pi relation? Hmm? Can you tell me pi relation? Relation? Just tell me pi relations. Relation. Tell me pi finite relations. Finite relations. Finite relations you can. R1 is a finite relation. Tell me finite relation. Relation.
Minus 5. So,
Finite relations on issues. So issue. What is relations on it? This is a set of integers. You know that, no? Set of integers, all positive and negative, all perfect numbers, including zero. There's a set consisting. It's an infinite set. Now this set is infinite, not like previously we discussed. Capital A is finite set. Right? Now we said it's infinite set. Infinite set. Set of integers. Set of integers. If you take set of integers, can you tell me relation, pi relations? R1, R2, R3, R4, R5. Hello?
so you're doing relation Z
All
and
Z.
set of integers.
Yeah. Can you tell me one relation?
The 1, 2, 3, 4, 5.
It's not a relation, it's a subset of Z. So you have to consider Z cross Z. What is Z cross Z? Partial product Z cross Z. Any subset of Z cross Z is a relation. Can you list out all the elements of Z cross Z? Z cross Z? Is it possible?
So Z is what?
Z is a set of integers.
Yes, set of integers.
Yeah, set of integers. Can you list out element of Z cross Z?
Yes, sir. 0, 1, 0, 2, 0, 3, like that.
No, you can never complete it. Because infinite set, it is infinite set, no? If you have finite set, then you can complete it. Can you remember that in previous example, A has 6 elements, then A cross A or 36 elements, 36 members. But Z is infinite set, Z cross Z is infinite, right? So how do you list out all the elements? You can never list out all the elements. If you want, you can list out just few elements of Z cross Z. Right? But you can imagine the shape of the elements of Z cross Z. You don't need to list out all the elements of Z cross Z. Without listing out, you can imagine how these elements look like. Right? Without listing out. Right, R1. If I write 0, 1, minus 4, 3, 0, 0 to 1 minus 7, 1. Is this relation or not? Is it?
This is infinite set, but here we are defining a set.
Yeah, it is infinite set, but relation can be defined so that it is finite. So this is a finite relation which is defined on infinite set procedure, is it? Using this term. This is infinite, this is also infinite, but this R1 is finite, so this R1 is finite relation. So this is a finite relation. Okay? Is it clear? R2. Tell me another one. Hello? Tell me another one. Hello?
We can put negative numbers.
Yes, it has negative numbers, no? Now, if you take minus 50, this is an integer. If you take minus 7, this is an integer. If you take minus 3, this is an integer. If you take 0, it is an integer. If you take 8, this is an integer. 9, so this is an integer. Right? There are infinite number of integers. Then you can choose any number except fractional and decimal numbers. Tell me another relation.
There will be 0 to
0, 2, okay.
1 minus 2.
1 minus 2, okay.
So it can be minus 2 minus 2.
Minus 2, minus 2, okay.
B2
2, okay.
to 1.
2, 1, okay.
So 2 6.
2, okay.
B4
3, 4, okay.
1 6
1, 6 is okay.
1 7.
1, 7 is okay.
So it's like we where to disturb. Where we should stop.
P value.
So 0 3
Is okay. Right. Then R3, 1, 1, 2, 2, 3, 3, 4, 4. R4, 2, 4, 4, 8, 8, 16, 16, 32, like that. R5, 100, minus 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, Process minus function. One minus one. 10 minus 10. Like that. So these are relations from regions. Can you define infinite relation? All these relations are finite relations. How do you define finite infinite relations? R6. Hello?
Yes, sir.
How do you define infinite relation? How do you list, is it possible to list out infinite relations?
No, sir.
No, it cannot be. So you have to give it in as a function. So like that, infinite relation always you can define like that. So if you take x, y, x equals y, and x, y belongs to Z. Okay. We are defining all relations of Z. No, you don't need to write xy belongs to Z because you know x and y are because you are defining relations on Z. All these relations are Z, right? Then how do you write them? So can you list out few elements of R6? Hmm? If I say 1 1 belongs, is 1 1 belongs to R6? Yes or no?
Yes, sir.
Yes, because what x equals y is 2 2 belongs to R2, R6? Yes. Hmm? Minus 1 belongs to R3? Yes.
Can you read the article? I cannot read what X, Y, then we put the bracket, straight lines, or what
This means xy, this is the element, shape of the element. Then this is the rule, how you set the element. This is x equals y is the rule of the relation, right? So using the rule, you can identify the elements, members of R6. Okay. So after this slash, from this slash, so define the rule. All these things, the rule. How you get, how you choose x and y. That's a rule. Okay, 1 1 belongs to R6 because one equals 1 to x. So this is x value, this is y value. X equals y, right? This is also x value, this is y value. X equals y. So you can write many members of R6 if you take minus 5 belongs to R6. Minus 4 plus 4 belongs to R6 or not? This one belongs to R6 or not? Hello? Minus 4.
Minus 4 belongs to R6.
Yes or no?
Yes, sir.
No, because minus is the minus 4 not is equal to plus 4. Is this true?
R6 is like the, what is the meaning of R6? R6
R6 is meaning this is R6.
X to Y belongs to this.
XY, then how XY? X equals Y. It should be equal to y.
So the x is
So this
equal
does
to
not
y.
belong to R6, eh? Minus 4, 4 does not belong to R6 because minus 4 not equal to plus 4. That
Yes,
is
but 4 is
not equal to plus 4. Therefore, minus 4 plus 4 does not belong to R6. Okay? Alright? Can you write another relation on R on a sheet? Let's say R7. I will write x, y. The rule you define as that x minus y is divisible by y. Another one. Another relation. But here R1 is a finite relation, R2 also finite, R3 also finite, R4 also finite, R5 also finite, but R6 is infinite relation. R7 also infinite relation, right? All these relations depend on Z, set of integers. Okay? Hello?
yes, sir.
Is it clear? Can you list out few elements of R7? Actually, you can never list out all the elements of R7. You can just list out few elements. Can you tell me 5 elements of R7? Hmm? Hello? I'm asking, there are infinite number of members for in R7. Out of those members, tell me only few members of R7. Hmm?
R7, sir.
Hmm?
R7 minus 1 is divisible by
Yes, x minus y should be divisible by 5. Then R7 includes, tell me few elements.
5.
Yes, good. 5 belongs to R7. Good. Tell me another element which is belongs to R7. Hello? Hmm? If you take 7 2, belongs to R7. Why?
Why?
Because 7 minus 2 equals 5. 5 is divisible by 5. 7 minus 2 is 5. 5 is divisible by 5. Then 12 2. 12 2 belongs to R7. No. Because 12 minus 2 equals 10. 10 is divisible by 5. 10 is multiple of 5. It is divisible by 5. Right? So if you take minus 7 2, no, minus 7 minus 2. So this minus 7 minus 2 equals minus 5. Minus 5 is divisible by 5. Okay? Belongs to R7. Minus 7 minus 2 is minus 5. If you take difference of these two numbers, it's minus 5. 3t belongs to R3 or not? You know, is this belongs to R7 or not?
But minus 5 is not divisible. So it's minus 5 divisible by 5.
Yes, minus 5 is divisible by 5. Okay. 3t belongs to R7 or not? Hello? 3t belongs to R7 or not? Hmm? 3t belongs to R7. Why? 3 minus 3 is 0. 0 is divisible by 5. 5 minus 5 also 0. Right? 5 minus 5 is 0. It is divisible by 5. 0 is divisible by any number. Right? Okay? Is it clear? The R7 is infinite relation. Suppose you are to write down a finite relation condition, so you can write down very easy. Can you show R6 and R7 are reflexive relation? R6 and R7 has reflexive property. Hello? R6 and R7, you can do that. R6 and R7 has reflexive property. What is reflexive property? Reflexive property. All x belongs to here. X belongs to R, R6, then R6 is reflection. Right? So it's obvious, no? Because if you take, you just but now R6 is this one. R6 is XY, X equals Y. Right? These are things. That means each, for all x belongs to here, x equals x. It's obvious. So therefore xx belongs to R6. Therefore It is reflexive. R6 is reflexive. If you take R7, what is R7? X, Y, X minus Y is divisible by 5. Now choose all X. Now you just consider so let X belongs to here. Right? Then X minus X is 0 is divisible by 5. Therefore, X belongs to R7. Therefore, R7 is reflexive. Okay? R7 is reflexive.
The reflexive in here, what the meaning?
Reflexive means you have reflexive means you have to check whether elements of now if you take elements like this 1 1 2 2 3 3 4 4 minus 1 minus 1 0 0 minus 2 minus 2 minus 3 minus 3 minus 4 minus 4 the elements of this kind of elements, all elements included in that relation, then we say it is reflexive. Right? Now R6 and R7 are infinite relations. So you cannot inspect member-wise. You cannot inspect member-wise. Taking all members. Just inspecting all members, you cannot check whether it is reflexive or not. But therefore, you have to just select single element, single member, right? Single element. You check whether that XX type element of XX belongs to R6. Right? Then we can say it is reflexive. Right?
So like, but I understand that 1 1 2 2 3 4 4. Like minus 1 and 1 is not considered.
Right? Minus 1 here, minus 1, minus 1. Eh? That minus 1 plus 1. Minus 1, minus 1. 0, 0. Here minus 2, minus 2. Eh?
Yes.
Minus 2, minus 2.
But then reflexive.
Yeah, then reflexive. Reflexive. 1, 1, 2, 2, 3, 3, 4, 4, minus 1, minus 1, 0, 0, minus 2. Right? Actually, you cannot check the reflexive property taking the members one by one, no? Because this is infinite set, no? Infinite relation, right? It's an infinite relation. Is it possible to check taking one by one? It's not possible, right? You cannot check the elements taken one by one. So you choose elements in general manner. What do you mean general manner means you just take XX. If you take XX, if XX belongs to R6, if X minus X is divisible by 5, right? So X minus X is 0, 0 is divisible by 5. So you can say XX belongs to R7. Okay, right? But in R6, all the elements are of this type, 1, 1, 2, 2, 3, 3. So therefore it is reflexive. Right? XX belongs to R6. R6 is reflexive. Okay, is it clear? Hello? So you can show R7 is reflexive, symmetric, and transitive. R7. Therefore, R7 is uh, R7 is equivalent relation. R7 is said to be an equivalent relation. If a relation has three properties, all three properties, that is reflexive, symmetric, and transitive, then we say that relation is equivalent relation. You can show this R7 is equivalent relation. Hello?
Sir,
So you keep in mind, definitely you might get this question, x minus y is divisible by 7, or sometimes we say modulo 7, modulo 5. X equals y modulo 5. What more? X equals y modulo 5, right? That is modulo, sometimes this is also known as modulo 5 relations. Suppose if you take x minus y is divisible by 6, that is also another relation, right? That is also equivalent relation, right? Okay. I will define new relation on this. Let's define a relation on shape such that R equals x, y, x minus y is divisible by 7. So that R is an equivalent relation. So that R is equivalent relations. How do you show this equivalent relation? Hello? If it is equivalent relation, you have to show three properties. Then we have to show.
So can you show up the theory?
Hmm?
Can you show up the?
Then we have to show one reflexive property, two symmetric property, three transitive property. Okay, reflexive property, symmetric property, and transitive property. Okay. Now, reflexive property is obvious, no? What is so reflexive property? So let x belongs to Z. Then x minus x equals 0. Okay? Is divisible by 7. Therefore, xx belongs to Z. Okay? Therefore, R is reflexive. Okay? Then first one. First one is okay. Then second one, how do you show? Second one. Let x, y belongs to R. Okay? If x, y belongs to R, then x minus y is divisible by 7. Okay? Hello? Is it clear?
So can you explain then we have to show that one.
So this is what we have to show. If you want to show this an equivalent relation, you have to show reflexive properties true, symmetric property also true, transitive properties true for these relations. Now, reflexive property, when you do the reflexive property, you have to take x belongs to Z, then you have to check whether xx belongs to Z. So xx belongs to R, sorry, R, here, notation. If just x belongs to Z, then x minus x is 0. 0 is divisible by 7, right? 0 is divisible by any number. Therefore, it is divisible by 7 also. So, therefore, xx belongs to R. Therefore, R is reflexive. Then xy belongs to R, then x minus y is divisible by 7, then y minus x also divisible by 7. If x minus y is divisible by 7, y minus x is divisible by 7. Okay. Therefore, yx belongs to R. Whenever xy belongs to R, then yx belongs to R. Right?
Okay. It is x and x belongs to R, and R is reflected.
Yeah.
Okay. Then x and y, that's the difference. X and y belongs to R, then x minus y can be given by 1. Then y is also like y also can be y minus x is also.
X minus y is divisible by 7, then y minus x also divisible by 7. For example, if you take 17, if you take 17, 3 is divisible by 17, 3 is belongs to R. Why? 17 minus 3 is 14, 14 is divisible by 7. Now if you take 317, 3 minus 17 is minus 14. Minus 14 is divisible by 7. 14 also divisible by 7. Minus 14 also divisible by 7. Therefore, whenever 17 3 belongs to R, then 317 also belongs to R. Okay. Likewise, when xy belongs to R, then yx also belongs to R. Right? If xy belongs to R, then x minus y is divisible by 7. Then y minus x also divisible by 7. Therefore, yx belongs to R. Okay? Therefore, R is
73 and 3 are 70.
Yes. R is symmetric. Symmetric. Okay? Then third one, you have to check whether transitive. What is transitive property? Can you remember transitive? A, B belongs to R and B, C belongs to R. If this 2 is true, then this implies AC belongs to R. So that's transitive property. So let AB belongs to R and BC belongs to R. If AB belongs to R, then A minus B equals 7K1. Okay? BC belongs to R, then so you can take this one. BC belongs to R, B minus C equals 7K2. Right? Where K1 and K2 integers. Where K1 and K2 belongs to Z. They are integers. Okay? Now you can add 1 and 2. So this you can take, this is 2, equation 2, y1 plus 2. If you take 1 plus 2, A minus B plus B minus C. Right hand side you have 7K1 plus 7K2. So these 7 times K1 plus K2. But here minus B plus B get cancelled. A minus K equals 7 times K. So 7K. So K1 plus K2 you can take K where K belongs to
where K1 and K2 belongs to Z.
Yes. K1 also belongs to Z, K2 also belongs to Z. That means K1 also integer, K2 also integer. Then if you take sum of two integers, also integer. K1 plus K2 is integer. So you can put K. K belongs to integer. So this means A minus C is divisible by 7. That means AC belongs to R. When AB belongs to R, BC belongs to R, then AC belongs to, you can prove that AC belongs to R. Okay? That means, what does that mean? That means R is transitive. R is transitive. Therefore, R has all three properties: reflexive, symmetric, and transitive. Therefore, R is an equivalent relation. Equivalent relation. Equivalent relation. Okay. R is an equivalent relation. That is how you prove equivalent relation. You might get this question for the exam. So you keep in mind. So because they might give any integer in can take, you can substitute any in. So this example, they might have different values. Instead of 7, you can have different integers. So they might say x minus y is divisible by 6. Then another relation, right? Then if you have equivalent relations, you can set equivalent classes. How to set equivalent classes? So we can discuss it next time. We discuss tomorrow, day after tomorrow. Equivalent relations, then you can prepare equivalent relations. So equivalent classes. If you have equivalent relation, always you can set equivalent classes. In equivalent classes means partial of Z. Z can be partial based on the equivalent class. Right? Entire integer set can be partial. So we discussed this one under group theory. Can you remember? Under group theory also we discussed this partial under equivalent relation. Under equivalent classes, under modulo, can you remember modulo when we discussed? Right, under group theory? Right, we discussed it. Like here also you can entire integer set. Set of integers can be partial based on equivalent classes, right? Okay, right. Any problem up to now?
No, sir.